All right, everybody, we're working on the surface area of this portion of this sphere that is inside the cone. Z equals x squared to x squared plus y squared. If we picture x squared plus y squared as r squared, like in the xy plane, as the circle gets bigger in the xy plane, z gets larger. So it should be making some kind of cone like that. And then we have some sphere that's got a radius of 4 going like that. So like inside the cone, it's like a snow cone that where the scoop doesn't fill all the way up. Now, if we want to look at it on GeoGebra, you can see this right here, like this. So there's some point where we're looking for this red part right here. And it's clear that the boundaries of it are where the two planes intersect. Not planes, but the two surfaces intersect. So let's take a look at where they intersect. Maybe get a little bit better idea of what's going on from that. God, that's a terrible graph. That was not a circle at all. Let's see that. That's a little bit more circle-ish. No, it isn't. God, it's bad. That's at least a little bit better.
Leave the graph for the computer.
You should be able to do this and sketch it and get an idea of what's going on without getting GeoGebra out. Too much reliance on technology is going to be the death of you. So, how do I get these equal to each other? Maybe square. Well, you can. I'm telling you, I'm advising you, don't rely on tech so much. You're not going to have tech on tests, and you're going to be required to do this. So practice graphing the shit by hand. Okay. So if we square this, we're going to have z squared equals x squared plus y squared. And if I could solve the other one for z squared by subtracting x squared and y squared over. So maybe I can find the surface where they meet by setting them equal to each other. And we'll get the x squareds and y squareds over there. And so we've got 8 equals x squared plus y squared. So let's keep that in mind. Let's take a look at the surface integral. We are doing, it's the surface of the sphere, right? So that's what we need to do dz for. So z, the sphere one was z equals square root of 16 minus x squared minus y squared. It might be a little bit easier to leave it as it was, actually. We take the derivative here with respect to x. I've got 2z dz dx equals negative 2x. So dz dx is negative x over z. And we already have z. We know what that is. It's the square root of 16 minus x squared over y squared. And when we do it the same with y, dz dy should look very similar. It should end up giving us negative y over z, because the inside hasn't really changed in terms of x or y. So we got negative y over square root of 16 minus x squared minus y squared. So our surface integral is the square root of those squared. I've got x squared over 16 minus x squared minus y squared plus y squared over 16 minus x squared minus y squared plus 1. And then I've got a dA. And if we get a common denominator, make this 16 minus x squared minus y squared over 16 minus x squared minus y squared. You guys with me? Slow down a second, make sure I'm not too fast. We can combine the numerators. We get 4 on, or 16 on top. Square root of 16 though is 4 over the square root of 16 minus x squared minus y squared. dA.
Hey, Mr. Jones,
Yeah,
in your DZDX, where did your 2 go? Is
it cancels with the 2 on the other side.
oh, okay, so it's just just an idiot. Okay.
I didn't
fair
actually write out that step because I thought it was apparent.
Wait, it cancels out. But when they're both, one's positive, one's negative.
Well, yeah, well, the negative's still there.
The negative is still there, but when we square it, the negative goes away.
Yeah.
I don't know. So
I'm
you're
thinking
taking, or is that's not implicit, is it? Or am I?
Yeah.
I did implicit, but we still got dz dx. I mean, if we took the square root, if you started with the square root of 16 minus x squared minus y squared, you're going to get this for dz dx.
Oh, okay. Sure. Oh, wait, that looks like something.
Right?
Yeah.
You got the derivative of the inside, and then this was to the 1/2, so it's negative 1/2.
Oh, yeah, the 2's cancel. 2 on the bottom and the 2 on the.
And the 2's cancel, and you got the square root on bottom. All right, so here we are. I don't really like the way that bottom looks, so let's look at this in polar. I could write this as
Yeah,
16
square.
minus
Didn't I say
x
x
squared.
squared over?
What?
Did you miss the square, or is that supposed to say x squared over 16 minus x?
I did not. I combined these fractions. This x squared cancels this negative x squared. This y squared cancels this negative y squared.
No, I'm talking about that one we circled, where it says x squared over 16 minus x minus y squared. And all the other ones say. Oh, never mind, okay.
I don't understand.
Rotation.
Where-
Not.
Oh, I see it.
Is one of the x's not have a square?
It's one of the x's you have just doesn't have a squared on in your first part in your x area. It's not.
There?
It's the one. Yeah, right there.
Except now they're the same.
That was clearly a mistake. Hopefully you saw that was a mistake and filled it in. So we have this as dA. I'm going to treat this as r squared. And so if I change this to r squared, I can shorten that a little bit, make it a little bit shorter. But now we're doing our integrals in terms of polar. So dA switches to r dr d theta. R comes from this. X squared plus y squared equals 8. So r is the square root of 8. And theta should be 0 to 2 pi. Because it's the full circle. So quick use of. And when R is 0, U is 16. And when R is square root of 8, U is 8. That should be fun. And I got a -1/2 times the 4. Maybe I'll write it just so there's no confusion. And then I've got U to the -1/2 du d theta. And this is now in terms of U. Now, my limits are upside down. I don't know that I really like that.
Just flip it for the sign.
Flip it and do the sign. Good, you guys remember. And I could multiply the 1/2 and the 4, but I know when I integrate, I'm going to go up a power and divide by the power. So up a power would be 1/2. I'm dividing by the 1/2, so the 1/2 will cancel. If I just leave it alone, I'm going to have the negative out front, and then I'm going to have -4 there. The 1/2s cancel, and then I have u to the 1/2 evaluated from 8 to 16. And I could separate out the integral of theta. So this is the du integral. The d theta integral, since they are now separable, I've got theta from 0 to 2 pi.
Wait, how can you pull out a 4 and not a 2?
With the original.
The square root of 16 is 4.
She didn't define them when he got going for this.
No, right, in your integral, when you like pulled out that, when you pulled out that, those constants, when you pull those out, shouldn't you pull out a?
When you integrate, you're 1/2 power. Well, you're not.
So when we integrate, we got u to the 1/2 divided by 1/2. And I just use this 1/2 to cancel that 1/2.
So.
So I've got 4, the negative is 4. And then I've got square root of 16, which is 4 minus the square root of 8. And then I got 2 theta, or 2 pi.
Do that.
This is 16 minus 8 root 2
Ideas.
times 2 pi.
Get practice doing it.
Why did you get practice?
Or 32 pi minus 16 pi root 2. That seems kind of ugly.
X squared plus.
Yeah.
But it is what it is.
Values. The bounds.
Well, where we get them?
So.
I just put the.
It's right there. And it choose. Talking to this. And. the no, no, that's why it's very sad.
Oh, I was wondering when you did that. You didn't even do anything with that.
Yeah,
Until now.
yeah, so I squared it, squared the A, and that's where it wanted to bounce.
Jones,
Yeah,
I'm a bit confused at the part we did implicit differentiation. Are you able to do it the other way?
Oh, I did.
Yes.
I did it.
Can you show? I mean, I don't know why I'm having such a hard time figuring this out.
I'll bring that back in a second. This is the same thing to the 1/2. So I bring down the 1/2. This goes to 16 minus x squared minus y squared to the negative 1/2. And then I do the derivative of the inside is negative 2x. So I got a 2 and then 2 here, they cancel. I got negative x on top. The square root of 16 minus x squared minus y squared on bottom, which is the same as the negative x over z that we got from the implicit differentiation. Sorry, I was off the screen. Implicit differentiation is still differentiation. It's just another way to do the derivative.
All right, I got it. Thank you.
So that's actually useful to recognize. Like doing this can be a pain in the ass.
Oh, I think that's
Starting with
easier.
z squared equals 16 minus x squared minus y squared. Doing dd or ddx here, that's just 2z dz dx equals negative 2x. And without having all that square root in there right away, you've got negative x, oops, that's a z. You've got negative x over z. So like doing the derivative a little bit easier with implicit differentiation because you can't fuck up the chain rule here. Right? There are students that people, shit, not just students, teachers fuck it up too. Every once in a while, I'll fuck up the chain rule. Do the derivative of the inside wrong. Doing implicit differentiation avoided the chain rule. And it didn't introduce the square root until the end. So they are both forms of differentiation. Whichever one is easiest, you should use. This will make taking derivatives easier if you adopt this mentality.
How did you get your bounds again?
We set the integral or the surfaces equal to each other because that's where they intersect.
Way at the beginning. He did
So
it.
that 8 equals x squared plus y squared thing?
Yeah, that's where we got that. And so when we converted to polar, that's where I got the radius is 0 to square root of 8.
Oh, okay.
That's what I was saying.
You guys ready for more? So well, this is the last idea in 14.4, and then we're gonna look at triple integrals and give you guys some tips on how to go about tackling the limits of integration and stuff there.
Yeah.
So when we're doing these X, or they're all functions of U and V. So we can get the tangent plane, recall with dr du cross dr dv, and taking the norm of that. So let's just write what R is, start there. R as a function of U and V is U squared, V squared, U plus V. So dr du is 2u 0, 1. And dr dv is 0, 2v and 1. And at the point 1, 4, 3, u squared equals 1, which is x, so u equals 1. V squared or y equals v squared, which equals 4. So v equals 2. And I know it's the positive versions because z has to equal u plus v. And so if either one of these is negative, I'm not going to get 3. Okay. Which means this makes RU, dr du is 2, 0, 1. And RV is 0, 4, 1. And we set up our norm, our determinant, or sorry, our cross product. For I get -4. J hat is 2 minus 0 is 2, but there's a negative out front. And I got 8 for K. So this is our normal vector for that tangent plane. So we've got -4 times x minus x naught, which is 1, plus y, which is -2, times y minus y naught, which is 4, plus 8 times z minus z naught, which is 3. Yes, we could have factored out a 2. Hell, we could have even factored out a -2 and made this 2, 1, and -4 and done the same thing.
But because of the vector.
So I've got -4x plus 4 minus 2y plus 8 plus 8z minus 24 equals 0.
Oh, nice.
Let's see, 4 and 8 is 12 minus 24 would be negative 12 equals 0. When I add it to the other side, I have to add it. You can't just put negative 12 on the other side. I say this because I saw it on the test, on multiple tests. Just the right side being the same side, like it just being moved over without sign change. And if I divide by negative 2, I'm going to get 2x plus y minus 4z equals negative 6. I happen to like that form a little bit better. I like the x being positive. And if we can reduce it, we can, but that's me. I would accept either version on the test, of course. If you guys are watching this at home or are currently or later on and you're not in Discord, you should hop in Discord and see all the pictures I took of people that did shit like divided by the square root of 1. I didn't put names, but there was, if I counted on my hands, it'd be more than one handful of people that had divided by 1 or divided by the square root of 1 on their test. Like, that's some like 2nd grade level mathematics right there. That shit should not be showing up on tests, divided by 1.
That's cautiousness taken into a new level.
It's too cautious. You're wasting time doing shit that you know better. Like tests, you have a limited amount of time. You're bothering to calculate and use a God help me if you're using a fucking calculator to do divided by 1. You should just drop the class now. You're not going to be an engineer.
Well, what if the universe, like, what if you shift to a different reality where it's not equal to the number? On the
Then
top?
you can go live in that universe.
Quantum mechanics.
I'm just being honest. If you're not like, you're so unsure of yourself that you're doing divided by 1 in a calculator, you're not going to make it. Trust yourself. At least with some basic mathematics shit. All right, so triple deckers, the triple integral. This is 14.5. Doing a regular rectangular region is pretty easy. It gets a little more challenging when we're doing integrals with weird boundaries. And so sometimes it's a little challenging to think about how to do it. So the steps you really want to take is you want to, remember, we got 3 integrals we're looking at. So we want the most fucked up one to be on the inside. So if there's a case where like one of the functions or one of the variables is a function of the other variables, put that shit on the inside because it needs to show up before we do the other integrals. So in this case, I said z for both of the examples I'm going to give. But if it was y was a function of x and z, then my picture would just be a different way. Once you have it, when you integrate that out, like let's say it's z here, when you integrate it out, what you're effectively doing is taking everything and it slams down onto the surface that you're projecting. And it becomes part of the function that's in the integral. But then this surface, this volume up here goes away. We need this XY thing right here. It's like a collapsing box. So as we integrate, we lose dimensions. Pictorially, and I used a wet erase and dry erase for this. When I integrate z on the box, this is what happens. I'm left with the XY. So before you do that, like the box, it was kind of easy. you have to project it onto the remaining surface. So if you're integrating out Z, you gotta see what the shape looks like on XY. In the video, we'll do this solid here in a second. In the video, I did a paraboloid. And it was along Y. So when I look down Y, when I integrate this, this kind of all slams down into the XY plane. And it's going to make a splatter mark that's a circle. Oh, that's great. I like that. Just like something got crushed and it's their fucking dead body splattered on the remaining plane. I don't know that I lined that up very well.
Episode of Place.
I don't think I lined that up very well. Let me realign that.
Yeah. First 10 minutes, the first 10 minutes.
So like their body just boom, they hit the ground, they fall, they splat. So
And the
we need to
math-
be able to identify what's going on in this projection. So we're
And in the
looking at what
mathematical,
happens
those
here.
people have to worry about blood splat. Because it's only in one circle.
Which is why I love it.
It's very much like a collapsing box. So like when you collapse the box, 2D goes down to, or 3D goes down to 2D. And then when you do the integration this way, that collapses down into a single line. And then you're integrating the line and that collapses down into a single value. So you're like, it's kind of like, to me, like I like picturing it like it's all just being crushed into a single point. First it flattens, then it flattens this way, and then it flattens that way. It's a Jones perspective on it. So that's what we're gonna do here. And I had that here set up to do that. So let's find this, let's set up the integral for the solid bounded by y plus z, oh shit, equals 1. I erased part of that. I'm getting hasty. Y equals x squared and z equals 0. Try to do this by hand and then we'll take a look at it in GeoGebra. In fact, I will get that set up while you guys are drawing it.
Find the solid. Are you just asking them to find what part of the solid is being bounded, or they're finding the volume, or what are they finding?
Find the volume.
Find the integral. Circle.
Take the
square
X, the last one. Take the D, the first. So, one. Yeah.
Okay, so if I was gonna try to draw this, y equals x squared. Y equals x squared is a parabola like that. And since there's no z component, it goes all the way up and down.
Wait, it's going. Oh, wait.
Y plus z equals 1. When z equals 0, y equals 1. I'll do this in a different color. When y equals 0, z equals 1. And x doesn't have a component, so it can extend indefinitely along this. So what I'm going to do is I'm going to stop it right there and go, okay, I've got this curve here, but this curve, the y equals x squared is going all the way up. There's this line where it's intersecting it like this. So I've got something that looks like that, like a doorstop. Because this is a curve. Let's see, how can I show this well like this? And then the plane is coming in and slicing it down like that. So it's going to follow along the curve where it slices. Maybe not the straight line I put.
Do the shapes. Get a lot more.
So it follows along the curve it slices and leaves that. So you can look at it in GeoGebra and we'll see the same thing. There's our y equals x squared. There's our y equals z. And we have this little wedge right here. So maybe like a heel on a woman's pump or something. That's, well, maybe not. That's a little weird shape for it, but that's what we're looking at. So how do we go from that to our limits? Well, we can project on, the easiest one to project onto is projected down onto the y equals x plane. So let's get rid of z first. So z's lower limit is 0. Z's upper limit is, we solve this for z, we get y minus, or 1 minus y. Once we've done that, we are now down to a two-dimensional surface, y equals x squared. But where do we stop it? It stops here and here. So that's where the y plus z equals 1 and the z equals 0 intersect. So we need to find out what those values are. So when I do that, z equals 0 and y equals 1. Y equals z plus, sorry, y plus z equals 1 are the intersections, or where they intersect. And clearly we just plug in the 0 and we see y equals 1. And if y equals 1, we've got x squared equals 1. So x equals plus or minus 1. So to finish out our limits, we can do for y, how is y's value going? It's starting at the x squared line. This blue pin's dead. I need to change it. It's starting at the x squared line and going up to the 1. So the x squared is the lower limit. And the 1 is the upper limit. And finally, we have -1 is less than or equal to x less than or equal to 1. What's that blue pen? Get another blue pen out. Handy. Does that make sense? You kind of have to sketch the picture. Try to do a sketch. See you, Ben. Try to do a sketch by hand before you go to GeoGebra, because you're not going to have GeoGebra on the test. And it's a useful skill.
I is equal to 1 minus 0.
I heard they have new technology, they can put some chip in their brain.
GeoGebra in my brain.
Just install it in your brain.
So you guys ready to solve it?
Those are calculator instead.
Well, isn't that what you're doing though when you're drawing like this? You're just installing GeoGebra on your brain.
No, I'm not installing a computer program in my brain.
Well, I'm saying by drawing, but being able to draw this just means you have your own graphing utility in your brain. Your brain is your graphing utility.
Yes. Your brain is your graphic ability.
That's my
Yeah.
Yeah, it's a multi, it's like it's a quantum computer.
Z goes from 0 to 1 minus y. Y goes from x squared to 1.
That's something.
And x goes from -1 to 1.
Look at it. It's a triple integral. I don't know, I'm so excited.
And since we're finding the solve, there's no function. We're just doing 1. So dz, dy, dx. We're just finding the volume. So I don't need f of x, y, z equals 1. When you're finding a volume. We are going to do more 14.5 on Monday. And we'll start 14.6. I'm recording 14.6 today.
Oh gosh, you put dz, dy, dz. As if that last one should be dx. There you go.
I do that a lot. I do swap z's and x's a lot. Oh my God, you have no idea how many times I've scribbled shit out in lecture notes, thrown pieces of paper away.
What order did you put it in?
It's fucking terrible.
You said the inner one has to be in terms of the
Have
function
you
of
ever
the variable.
considered not using pen?
So
Oh,
let's solve it.
Outside.
Okay, so that I use this.
So you want the x to be on the outside.
The way I set it up, this x is on the outside. Because y, z is a function of y, y is a function of x.
Oh,
So,
okay. That's why
We
you wanna
have to do those first. And that also makes it so it's not separable. So I got -1 to 1, x squared to 1 of z from 1 minus y to 0 gives us 1 minus y there.
the outer one in the house, and that's.
I've got y minus 1/2 y squared x.
Wow, and we're 15. That's comments and part 2.
I've got 1 minus 1/2 minus x squared minus 1/2 x to the 4th dx. So what is that? -1 to 1 of 1/2 minus x squared plus 1/2 x to the 4th.
Plus 10, 1/10.
So -1 to 1. I got 1/2 minus 1/3 plus 1/10 minus -1/2 plus 1/3 minus 1/10.
Practice intervals.
So 1/2 and negative 1/2 is 1. And -1/3 minus 1/3 is minus 2/3. And 1/10 minus plus 1/10 is 1/5. So common denominator, 15/15 minus 10/15 plus 3/15 is 8/15. No calculator needed. Practice your fraction skills too. And let me know if I'll see you guys on Saturday. Or
I'll be
Sunday.
holding my new SI hours from 4 to 5 tomorrow.
I'll be there on Saturday and Sunday.
Same here.
Awesome. I figured Lawrence and Eric will be there, and Carlos is usually there. David's there half the time.
So if you needed to make a new word, like.
James when he's feeling bored. Have a good day, guys. Gals.
Oh, that's actually an alphabet. Where there's a couple alphabets, all alphabets use one letter, but like you